In this video, we're going to look at trig expressions of the form a cos theta plus b sin theta. It can be shown that these expressions can be written as single trig functions. We can either have r cos of theta plus or minus alpha or r sin of theta plus or minus alpha. This particular form gives us a stretch in the y direction and a translation in the x direction of the original trig function. If we have an expression in this form, we can use it to solve equations and find maximum and minimum values of some particular functions. Let's take an example now. Let's say we've got 4 cos theta. So we'll take 4 cos theta plus 3 sin theta. And we were told now that theta was going to be between 0 and 360 degrees. And we wanted to solve now where 4 cos theta plus 3 sin theta was equal to 0. With this particular equation, we could simply now subtract 4 cos theta from both sides. So I'd have 3 sin theta is equal to minus 4 cos theta. I could divide both sides by cos theta and both sides by 3. So we'd have now sin theta over cos theta would be equal now to minus 4/3. We know the identity sin theta over cos theta. That would give us tan theta. We'd have tan theta is equal to minus 4/3. We'd go ahead, solve the principal value, and then consider subsequent solutions in this interval. So we've looked at an equation like this before. Now what happens if the right hand side of this equation was not 0 and we couldn't use this particular identity? So let's say, for example, now this was set to 1. So if we had now 4 cos of theta plus 3 sin of theta is equal to 1. The form r cos of theta plus or minus alpha or r sin of theta plus or minus alpha can help us with these particular equations. We could also look now at plotting a particular graph, and we could look at plotting the graph now y is equal to 4 cos theta plus 3 sin theta. So if I wanted now to draw a sketch of this, I've got some idea of particular points on this graph. I can't do them to the exactly, but we can have some idea. So for example now, if theta is equal to 0, we know that the sine of theta is 0. So we'd have 4 cos of 0. Cos of 0 is going to give us 1. So we know that we'd have this point just here, and we'd have now 0, 4. If we consider pi by 2, if we think about pi by 2, well, cos of pi by 2 is going to be 0, and then we've got 3 sine of pi by 2. Sine of pi by 2 is going to give us 1, 3 lots of 1. So here we're going to have now this point, and that's going to be pi by 2, and then we're going to have comma 3. So we got some idea where that is. If we took pi and we consider sine of pi is going to be 0, and then cos of pi is minus 1. So we're going to have pi, and then we'd have, so pi is going to be just here. We've got pi, and then we've got minus 4. So looking at this, we could pick some values, but this doesn't give us now the complete picture of this graph. So in the video, what we're going to look at doing is expressing this particular form, a cos of theta plus b sin of theta, in either the form r cos of theta plus or minus alpha or r sin of theta plus or minus alpha. To understand that particular form, we're going to go back to the addition formulae or compound angle identities. So if I write this out now, I'll have r cos of theta, and then we'll have now, let's take plus alpha. So if we have now r cos of theta plus alpha, if we expand this out, we have r cos theta cos alpha, and then we have now minus r sin theta sin alpha. If we have now r cos of theta, and we can write this out, r cos of theta minus alpha, if we do this one, we're going to end up now with r cos of theta cos of alpha, and then we'll have plus r sin theta sin alpha. If we take the sine function, we've got now r, and we'll write it here, r sine of theta plus alpha. If we expand this out, we're going to get now r sine theta cos alpha, and then we'll get plus r cos theta sin alpha. And if we did it now with a negative, we would end up with r sine of theta minus alpha is going to give us r sine theta cos alpha, and then we're going to have minus r cos theta sine alpha. So this is something that we looked at before. In this particular case, r and alpha are constants. So we're going to look at finding those particular values and use a method to do it. But the whole idea of expressing a cos theta plus b sine theta, or any particular configuration of that sort, is to use the addition formulae and expand these out. So let's go ahead now and look at this particular equation that we've got, and to begin with I'm just going to consider it now as an expression. So we'll take 4 cos of theta plus 3 sine of theta, and I'll write it just here. So 4 cos theta plus 3 sine theta. In the exam, you'll generally be asked to express it in one of these forms, and that form you'll be given. So what I'm going to do is now express this in the form r cos of theta minus alpha. So we would have now 4 cos of theta plus 3 sine of theta, and we would say now express, so we'll say express in the form, just jotting this down, in the form now r cos of theta minus alpha, and we might be asked now to find r and alpha and write those down. So let's go ahead now and use this particular expansion. So what we've got then is r cos of theta cos of alpha, and then we're going to have now plus, so we can write plus r sine of theta sine of alpha. At this stage we equate coefficients. So if we consider now what we've got here, and I'll just highlight these, we've got here 4 cos of theta. So if I just highlight 4 just here, and we look here, this is r cos of alpha. So all I'm doing now is equating the coefficients on the terms in cos theta. Therefore, what I can write now is r cos of alpha would be equal to 4. If I now look at the expression we have for sine, we've got now the coefficient is going to be 3, and we've got here sine theta, so we can say now that r sine alpha will be equal now to 3. So let's go ahead and write that. So what we can say at this stage, I'm just going to write it now as r sine of alpha will be equal to 3. We've got now r cos of alpha is going to be equal to 4. The value of r gives us the scale factor stretch in the y direction. So if we look at this particular form right here, r cos of theta minus alpha, this is the cosine function stretched in the y direction by a scale factor of r, and then translated horizontally to the right by now a value of alpha, assuming that alpha is positive in this particular case. Now the general convention is when we put it in this form, it is positive. So what we have is a value of alpha, and that value is an acute angle, and then we also have a positive value of r, and we'll look at that as we go. Okay, so how do we get r from here? So what I'm looking to do in this particular case is find r and find alpha. If we look here, we've got r sine of alpha is 3, r cos of alpha is 4. Let's go back now to a trig identity. We know that sine squared theta plus cos squared theta will be equal to 1. So what I'm going to do is square these and add them. So if I square now r sine alpha, we're going to get r squared sine squared alpha will be equal now to 3 squared, which is 9. If I take now r cos of alpha and square it, we get r squared cos squared alpha will be equal to 4 squared, which is 16. I'm going to add these and factor them. So what we're going to have then is r squared is a common factor. We're going to have sine squared alpha plus cos squared alpha, so cos squared alpha, and that will be equal now to 9 plus 16, which is 25. If we go back to this expression here, we can see now that this is going to be equal to 1, so we can say that r squared is equal to 25. So r is going to be plus or minus the square root of 25. We take the positive root by convention, and we have that r is 5. So straight off now we can see that I've got 5 cos of theta minus some angle right here. Now if we go here, what we can see, we got this point 0, 4. This now is telling me I've got this point which is going to be here, and this is going to have now a maximum value of 5, and then we're going to have a minimum value of -5. So we can see now that this scale factor stretch, by finding the value of r, has just transformed a cosine function into one with a scale factor stretch of 5. So when you're carrying out this process, when you're looking to put it in this form, you need to find the value of r. We find the value of r by simply saying now that r, and I'll write this out, r in general is a positive value, so we say r is greater than 0, and r is given to be the square root of a squared plus b squared. So you don't have to go through the rigmarole of doing this each time. All you need to state is now that r is going to be the positive square root of a squared plus b squared. So for example, if I had now 2 cos theta plus 5 sine theta, it'd be the square root of 2 squared plus 5 squared. So all we do to find r is this. So if you want a very mechanical process, you jump straight here. Okay, so how do we find alpha? Now, alpha is just an acute angle. This is telling me what translation in the x direction I've got, because we're going to have this curve, and we can see quite clearly now that if I've got this maximum value of 5, the maximum used to be here. So we can see that we're going to have a horizontal translation. So let's go ahead now and do that. We can go back to this point right here. So what I want to do is find alpha. So I've got r sine alpha is equal to 3, r cos alpha is equal now to 4. If I divide these, the r's are going to cancel, and I'm going to have now sine alpha over cos alpha will be equal now to 3 over 4. That gives me now that tan alpha will be equal now to 3 over 4. That's using the identity, but sine alpha over cos alpha is tan alpha. Therefore, alpha is an acute angle such that the tan of, or the inverse tan now of 3 over 4 is that angle. Now, in this particular case, when we have it in this form, we have now that the value of alpha in general, when it's in this particular form, alpha is going to be now the inverse tangent of b over a, as we've got now a cosine. So all I'm doing is taking now the value of that I'm finding for the sine just here, and then dividing it now by the value of the cosine and taking the inverse tan. So let's go ahead. Let's see what we'll be doing this one in. We did this now in, I suggested to do it in degrees. I plotted now in radians. We can do this in radians or degrees. Let's go ahead and do it in radians, and we'll find a value right here for alpha. So alpha is going to be now the inverse tan of 3 over 4. So in the calculator, let's do shift mode 4, and we'll take the inverse tan now of 0.75, which is 3/4. That gives me now 0.6435. I'm going to give that to 3 significant figures. I'll leave that value in the calculator, but that's going to give us now that alpha in this particular case will be equal to 0.644 radians. And remember, alpha and now r are constants. So what we can now do is say that our value of 4 cos theta plus 3 sine theta can be written in the form now, the root of 25, which is 5, cos of theta, and theta now is the independent variable, and then we're going to have now minus 0.644 radians, and that now is in the form r cos of theta minus alpha. So let's see what that would do graphically. If I now took the curve, let's just start off with a nice standard cosine curve. We know that the cosine curve looks something like so. So we're going to come up. Now that value is going to be 1, we'll come down to 0, then we'll come down to -1, we'll turn back round, we'll come back up to 0, and then we'll finish off now coming here. Okay, so what's happened to this? Well, I've put now a scale factor stretch of 5 in the y direction. So whilst this isn't going to be wholly accurate, we'll have some idea. So let's say that this now was the scale factor stretch of 5. So what we've now done, we've come up to this maximum point, and it will be a maximum as it's a cosine function. We've come back round like so. We've come down, and we've come to the point just here. and then we come down to a minimum, and we'll put the minimum just here. Let's say that's the minimum. I appreciate that this isn't wholly accurate in terms of the scaling, but it'll give you some idea. We'll come back round like so, and then we'll come to the bottom. So what I've now done is put this scale factor stretch of 5 in the y direction, and that now is the value of r. So that's this part right here. What we've then done is translated now the curve of 0.644 radians to the left, sorry, to the right. So what we've done, let's consider this point here. This point is going to be 0, and then we're going to have 5. So when x is 0, or theta in this case is 0, we're going to get y is 5. Assuming this graph is y is equal to 5 cos of theta minus 0.644. What I'm going to do is now pick this up, and it will come in bits. Let's move this one, let's move that one, let's move that one, and all we've done now is translated this. So if we consider now where the maximum was before, so the maximum here was now at 0, 1. What we've now got is a maximum at this point. Now this point is going to be where we've got now, instead of 0, I've translated this, so this is going to be now 0.644 radians, and we're going to have a maximum value now of 5. If we look at this point now, we had pi by 2, 0, so this now is pi by 2 plus the 0.644, and then we've got now 0. If we look at the minimum point on the curve, before this was now going to be pi, minus 1, so this point now is going to be pi plus the 0.644 radians, 644, and now we're going to have minus 5. So all we've done here is put a scale factor stretch on of 5 in the y direction, and then now added 0.644 radians to each of the coordinates, the x coordinates, or the values of theta. So this is a rough sketch, and you may be asked to show now what this looks like. So that's now 4 cos theta plus 3 sin theta, or 5 cos of theta minus 0.644 radians. So as you can see now, this is our first positive maximum, and lots of questions will ask you where the first positive maximum is. And you can simply consider now that in general, the cos of theta plus or minus alpha will give us a maximum of 1 and a minimum of minus 1. You simply locate that and just move it. So for example now, let's take sine theta. Let's say we've got a sine curve. So say now, remember alpha is always going to be an acute angle, and this now will help you out finding where the first maximum and minimum occur. So this is y is equal to the sine of theta. So say we had now y is equal to, let's go for 3 sine of now theta minus, and then we'll just have say, let's say 10 degrees, okay? So if we look now, this is our first positive maximum. We know that this is always going to have a value of 1, and it's going to have a minimum for the sine curve of minus 1. So what's happened here? Well, we've put a scale factor stretch of 3 on in now the y direction. So we're going up to this maximum now, and this will be slightly easier to show as now I've got enough room. So we'll have now this point right here, and then we'll come down to a minimum at this point now, which is going to be minus 3. Now when I'm talking about maximum and minimum, or maximum and minimum, we've got to be careful when we use this, certainly with particular functions. Now when I'm talking about a maximum, I'm looking now at the particular graph, and this would be called a maximum point, and this would be called a minimum point. And we're just going to have to bear that in mind later. So what we've got now is this point right here, which is going to be positive 3, and it's going to be minus 3 here. If I pick this up by 10 degrees, what we're going to do is move it now 10 degrees to the right. So before, if I had now, and I'll just jot this here, the maximum here is going to be at pi by 2, or we could say 90 degrees, and then we'd have a value of 1. This is going to be 100 degrees, and we're going to have a value of 3. So I've simply stretched the y coordinate by 3 and added now 10 degrees to the the theta coordinate, or the value of x, whatever we've got along here. Now, if we were asked to find the first positive minimum, consider now that it's going to be this point right here. Now, before, this point was 270 degrees minus 1, so this is going to be 280 degrees minus 3. So we moved it 10 to the right, scale factor stretch, now a 3. And you might say, well, isn't there one coming from round here? Well, if we look now at the first, and let's just draw the sine curve now to the left, we've got now our first negative, so our first minimum point just here, and that's going to be now at minus 90, comma, minus 1. So quite clearly, now if I added 10 to that, that would give me minus 80, then put the scale factor stretcher through and it would be minus 3. That's not the first positive minimum. So the first positive maximum is 100, comma 3. The first positive minimum is, let's get around there, 280, comma, minus 3. Okay, let's go back now to the original. So what we've got, let's see it here. Say we have this 4 cos theta plus 3 sin theta. Now before I solve this for theta, 4 cos theta plus 3 sin theta was equal to 0. And we could see now that tan theta was equal to minus 4/3. And we'd go ahead, get a principal value and solve it. I didn't actually solve it. But what happens now if the right hand side of that equation is a constant? Let's say we've got now that this is going to, let's set this equal. Let's make a nice straightforward one. So let's say we've got now on here, and we'll take 4 cos theta, and then we'll have plus 3 sin theta. And let's say, and I'll make this nice and straightforward. Let's say now that this is equal to 5. We will let theta be between 0 and 360 degrees. Now, it's not always going to work out this nice for you, but if we consider what we've got 5 cos now of theta minus our 0.644. So in fact, let's just solve this in terms of, let's just go to 2 pi, okay? As we're working in radians before, we'll keep that there. So 0.644 radians, and that's going to be equal to 5. So if we consider now, we've got cos dividing both sides by 5, cos of theta minus 0.644 radians will be equal to 1. So what we would do is get a principal value for this. Now if you consider our principal value, just going back to the sketch of the cosine curve, this is nice and straightforward. So if we take the inverse cosine of 1, we're going to end up with 0. So what we get is something looking like that, and then we'll come up and we'll have something like that. So what we can have now is the following. We can say that theta minus 0.644 radians will be equal now to 0. And by symmetry, we can see that we're going to have one the same distance back from 360. So we could say 0 minus now, theta minus 0.644 is going to be equal now to 360. So we're coming back. Essentially what we're doing is finding this one, which we're going to have now. And we can write this as, and I'll just write this here, we're going to have on here. So let's put this on, we're going to have 360. So let's put that there. So that's going to be, and we're working in radians, so that's going to be 2 pi. Okay, so let's see what we've got now. Remember, this is going to be our original. So we've got now that this point is 0.644. Now, just consider what's going to happen here. We've got now, so the first solution is going to be now theta is going to be equal to 0.644. If we consider the next solution though, just think about what's going to happen. We're going to have 2 pi minus that, so it's going to go outside the interval. So we can see in this particular case, the only value that's going to satisfy this one right here is going to be theta is equal to 0.644 radians. Because if I add, I'm going to go outside my interval here. So all we're looking at now is a shift now to the right. So in other words, we've only got one maximum in the particular interval, and that now is going to be at the 0.644. So let's look at this graphically and have a good sketch. So if you ask to solve that equation, I kind of just made that up as I'm going, but hopefully that gives you some idea that we're only going to get now one solution in the particular interval as this maximum has gone outside. But if we had some other value, let's say we set this now to, let's go for, say for example now 3. If we had it to 3, we'd have now 3/5. We would solve for a principal value and then find our solutions. Okay, so let's look at this graphically to see what we end up having. So this now is going to be our graph, and I'll just do this. This is going to be, and we'll write it here, y is equal to, and we can either write this as 4 cos theta plus 3 sine theta, or we could write this as y is equal to 5, and then we've got cos of theta minus the 0.644 radians. So we can see now that this is the maximum point, and this point is at 5. So we've got now, we're going to have, this is going to be the 0.6, let's write that, 0.644, and then we've got a maximum of 5, and we can see that this point right here is now pi plus that value, and that's going to be then pi, and we could work out a numeric value for this, pi plus 0.644, and then we got comma minus 5. We can see before the cosine curve would have crossed the coordinate axis here, it's just now moved on. So that's our horizontal translation, and this is our stretch in the y direction. We might also be asked to find the maximum and minimum values of a particular expression. So let's look at an expression. Let's say we were asked to find now the maximum and minimum values of a slightly different expression. Say we were given now 4 cos theta plus 3 sine theta and then plus 2. So we were asked now to find a maximum and minimum for this particular expression. Well, we know that we can do now this as 5 cos of theta minus 0.644. Just consider what's happened here. All I've done is taken now the original expression and translated it up by 2 units. So if we think about what this is going to do, and I'll draw a quick sketch. This point now was minus 5. What we're now going to have is the point minus 3. So all we're doing is just now moving the whole graph up. So this now is a translation. So I'm going to add 2 to the y coordinate, and this point right here is going to go from 5, and it will go off here, and it will go up to 7. So we'll have 0.644, 7. So with these particular expressions, all we're doing is looking now at adding an additional value. So if you see something like this, and you're asked to find now the maximum and minimum values of this particular expression, you can consider now a translation in the y direction. So you go ahead and put this particular part in the form Rcos of theta plus or minus alpha, whichever form that you're given, and then you go ahead and add 2 to the y coordinates. Okay, let's go ahead now and solve another equation. So let's say we've got now, we'll have, let's take root 3, we'll go for root 3 cos theta plus sine theta, and we will let this be equal now to 1. Let's take theta, and we'll work in radians again. Theta will be between 0 and 2 pi. At this stage, we've got a couple of choices. Let's look at this form right here. Now, if I look at the form Rcos of theta minus alpha, if I expand this out, I'm going to have Rcos theta cos alpha plus Rsin theta sine alpha. So we could use this particular form. So if we look here, we can see that Rcos of alpha is going to be root 3, and we can see that Rsin of alpha is going to be 1. I could write this in the form sine theta plus root 3 cos theta, and we could consider now Rsin of theta plus alpha. I actually prefer working with the cosines, as often you're dealing with less negatives in your work. It's entirely up to you, or you will be given a particular form in the exam. So if we did this one, we'd have r sine theta cos alpha, and then we'd have now plus r cos theta sine alpha. So you can see in this particular case, r cos alpha is going to be 1. So we can say from here now, let's put that there, r cos alpha, because we're equating the coefficients, is going to be 1. And we can see that r, and then we're going to have sine alpha is going to be root 3. So you can see now that we're going to get the same value of r, but we're going to get different values of theta. But we know with the sine and the cosine, if we have cos of theta, it's the sine of pi by 2 minus theta, or 90 minus theta. And hopefully that gives you some idea of why, or at least why you can write it in 2 different forms. As stated, I prefer to work with this such that we're moving now our translation to the right when we do our value of alpha. So let's go ahead and do that. Now I've just done that and just put it in this form. So if we were asked to put now this particular expression on the left hand side into a form r cos of theta minus alpha, I can see from here that r cos alpha is root 3, r sine alpha is 1. So let's write this out. R sine alpha is equal to 1, and then we got r cos alpha is equal now to the square root of 3. Now you'll probably see in the last one I did this first. I did r sine alpha over r cos alpha. The reason I do that is often we forget that we're going to find tan alpha, and you can just see it slightly easier that way. But if I divide these two, I'm going to get tan alpha. Okay, so let's look now at the value of r. R is given to be, and it doesn't matter which order you do this in, root 3 squared plus 1 squared. So we can see that r is going to be the square root of 4, so we can say that r is going to be equal to 2. By convention, we take the positive root. So that gives me my scale factor stretch now in the y direction. Okay, so let's now look at alpha. So what we've got then is r sine alpha over r cos alpha is going to give us now, and we'll write this out, we've got sine alpha over cos alpha. The r's are cancelling, and that will give me 1 over root 3. So we can say tan alpha, using the identity, will be 1 over root 3. Now that's one of our special angles. We're working now between 0 and 2 pi, so it's in radians. So we can say alpha is equal to the inverse tan of 1 over root 3, and that's 30 degrees or pi by 6 radians. So again, this is working out quite nice for us. We get an exact value. So I've now got r and I've now got alpha, and all we need to do is put this back together. So I can say that this particular part of the equation on the left hand side is going to give us now 2, and then we're going to have cos of theta minus pi by 6 will be equal to the right hand side, which is 1. So we got a nice straightforward equation solved. Now on this, if you were very, very switched on, you didn't really have to do this. You could have looked at the addition formulae and considered now the following. That if we look now, we've got root 3. Now if this was root 3 over 2, that would give me the cos of pi by 6. If I had 1/2, that would give me the sine of pi by 6. So using the addition formulae, you could have said that we've multiplied this particular expression by 2, and we would have had 2 lots of the cos of minus pi by 6. If I just write this out, let me just sort of show what I mean. Cos of theta minus pi by 6. Now this was when we worked with the addition formulae. We would have written this out, cos of theta, cos of pi by 6, and then plus sine of theta, sine of pi by 6. So if we look at this, what we're going to get is root 2, so we got root 3 over 2 cos theta plus 1 over 2 sine theta. So if you sort of said, well, actually that looks like something I know, then you could simply multiply this now. If I multiply this by 2, what we're going to end up with is that, okay? And you can see now what we get. But again, if you're asked to do it in this particular form, you're going to work with this particular form. So that's what we got. We've got to now solve this equation. Now, this is going to be fairly straightforward as we've got theta between 0 and 2 pi. So all we would do now is say that theta, so let's divide both sides by 2 and take the inverse cosine of both sides. So we've got now theta minus pi by 6 will be equal to the inverse cosine now of 1/2. So that gives us our special angle. So we've got theta minus pi by 6. The inverse cosine of 1/2 is going to give us now pi by 3. That's a special angle, 60 degrees. Then the other one is going to be 60 degrees back from 360. So that's going to be 5 pi by 3. So if we go ahead and solve for this one, if we add now pi by 6 to pi by 3, we're going to get theta is equal to pi by 2. And if we add this, we're going to now have on here, let's look at that. So if I switch this up, that's going to be 11 pi. What's that going to be? 11 pi by 3. So that's 10 pi by 6, 11 pi by 6. So theta is going to be equal to now 11 pi by 6. I'm kind of doing that in my head a little. But all I've done here is said that this is 2 pi by 6 plus pi by 6, which is 3 pi by 6, which is pi by 2. Now, if we think about these are fairly logical. If we put them back into here, we can see quite clearly that the cos of pi by 2 minus pi by 6 is 1/2 because it's a cos of pi by 3. So these are our two solutions. And again, take your time, put them in, but that should give you what you're looking for. So if we're asked to solve the equation, we've got two solutions in that particular interval. So all we're looking then is simply now a horizontal shift. So we know that we'd have two solutions in the usual interval for theta, and just now putting the translation on means that we're still going to have these two values. What if we were asked to find now the maximum and minimum expression for this expression and state where they are? So let's just draw this then. So let's take now the cosine function. So we've seen the cosine function. The cosine function does something like so, and I'll do it a bit smaller this time. We've got now a minimum point, we'll come back up, we'll come up to the maximum. So we know on the usual cosine we've got 0, 1, and we've got this point which is going to be pi, minus 1. So what's happened with our expression here? Well, what we've done now is put a scale factor stretch of 2 on. So it's going to now be twice as high. So let's first do that. So it's going to go through that point 0, 2. We're going to come round here, then we're going to come down, and then we're going to have this minimum, and that's going to be now a value of minus 2. Let's just keep on here. Let's just extend that a little, and then we'll come back up, and then we'll come round like so. So all I'm doing is first putting the scale factor stretch on. So this is the 2 part, okay? Now what I'm going to do is move this, and I'm going to move it pi by 6 radians to the right. So if I pick this up, what we're going to have now is something looking like that. So what we've got then is a maximum value. The maximum value is going to be 2. Now all I've done is move this pi by 6. So it's going to occur at pi by 6, and it's going to have a value of 2. This one is at pi, so we need to add pi by 6, which is going to give me 7 pi by 6. Just consider pi is 6 pi by 6 plus pi by 6, and this is going to be minus 2. So this is a maximum value of the expression, so max, and then this is going to be the min. So that's where it is, and where, if you ask where it occurs, well, it occurs just here at pi by 6, 2, and then 7 pi by 6, and it's minus 2. Obviously, all these equations aren't going to be that nice in terms of these horizontal translations or the scale factor stretches. I'm coming up with integer values. But for example, now if we had, let's say we had, let's go for 5 cos of theta, and then we've got now, let's say we've got plus 2 sine of theta. If we consider our value of r is going to be the square root of 5 squared plus 2 squared. So we've got now a scale factor stretch of a root of 29. Again, we take the positive value, so root 29. So yes, we've had integer values, and yes, I've had quite nice values of alpha, but it's not always going to be the case, so do be aware of that. Okay, let's move on. Now, we can use this form, r cos of theta plus or minus alpha, or r sine of theta plus or minus alpha, to solve more complicated problems. So let's say we had now, let's take something else. Let's say we've got now 2 over sine theta minus cos theta. So if we look now, we've got 1 sine theta minus 1 cos theta. We might be asked to find the largest and smallest value of the fraction. At this stage, it's massively important to understand that this is not necessarily the maximum and minimum point of the function f of theta. And we'll look at that as we go. So let's deal with this. So what we want to know is what the largest and the smallest value of this fraction is going to be. Let's take this here. We could put this in a form, and generally you'd be given a form. I'm going to put this in the form r sine of theta minus alpha. Why have I done that? Well, I've looked ahead and I see now that if I expand this particular form out, I'm going to get r sine theta cos alpha minus r cos theta sine alpha. So let's go ahead and do that. Let's just write this out. So r sine theta cos alpha, then we're going to have now minus r cos theta sine alpha. So if we look at this, we can go ahead and equate the coefficients. So we can see on here that r cos alpha is going to, and all I'm doing is picking this part up and this part here. We can see that's 1, and then we can see on here now that r sine alpha is also going to be equal to 1. So that's what we've got. Let's just look at those as we've got now a simple case. These are both 1. And again, we can see that that's obviously not going to be the case. So for example, now I'll just write it here. If I had 3 sine theta minus 2 cos theta, if we now equated the coefficients, we could say in this particular case then that r cos alpha was going to be 3, and we could say that r sine alpha was going to be 2. Don't get confused and say it's minus 2, because we've got this particular form. So let's go ahead and write that. So what we've got then, we've got now that r sine alpha is 1 and r cos alpha is 1. So r is going to be the square root of 1 squared plus 1 squared, which it will need to show me exam. So r is going to be the positive root of 2. So that's now got us sorted there. So we've got now, and I've written it the other way around now, because we've got 1 and 1, we can say that sine alpha over cos alpha is going to be equal to 1 over 1. And again, as stated before, I prefer to write this originally as the sine over the cosine, but as we've both got 1, it doesn't matter there. So tan alpha is going to be equal to 1. Therefore, alpha, again, we get a nice value, and we're going to say that this is going to be, we'll just take this to be pi by 4, or we could say now 45 degrees. It really doesn't matter. In fact, we'll work in degrees, as I've been hitting the radians quite heavily. So tan alpha is equal to 1, therefore alpha is 45 degrees. So we could write this now as root 2 sine of theta, and then we can have minus 45 degrees. So that's now putting the denominator of this fraction in this particular form. So what I could do at this stage is actually write that this is 2 over root 2, and then we're going to have sine of theta minus 45 degrees. At this stage, I'm just going to rationalise it. So multiplying the top and bottom by root 2, that's going to give me 2 root 2 over 2. So we've got now root 2 over the sine of theta minus 45 degrees. Now this might start looking, you might recognise this as a particular identity that we could use. Now let's look at the greatest and least value of this fraction. So if we think now the sine of theta, let's just consider now, if I think of the sine of theta has a maximum and a minimum. So let's just go ahead and put this on. The sine of theta has a maximum value of 1 and a minimum value of minus 1. So let's straighten this up. If we consider what's going to happen to this fraction, we can have values very close to 0. Okay? So if we have now, let's take these points just here. We've got two values that are very close to 0. We've got one positive and one negative. So if we think this fraction can get absolutely huge, so for example, if I divided now root 2 by positive 0.00001, that is going to be massive. In the same way, if I divided it now by negative 0.001, it's going to get incredibly large negative. So we can say that the maximum value of this particular, or the greatest value we should say, the greatest value, so the greatest value is going to be now positive infinity. It's going to tend to positive infinity. The least value is going to be now in the opposite direction. We can make this fraction as big as we want or as small as we want. So that's what we're making. We're making it hugely positive or hugely negative. And that's as a result of understanding what happens to the sine function. Now, that is the largest and smallest value of the fraction. If we were now told that this was the f of theta, let's now say this is the f of theta, and we were asked to find the values of the maximum and minimum points, that differs in terms of the question. Let's rewrite this now. Let's go ahead and write this, and we can say that the f of theta, using now a trig identity, we know that sine theta is equal now to 1 over cosec theta, or we could say that cosec theta is going to be equal to 1 over sine theta. So let's see how we could write this. We could actually write this as root 2, and then we're going to have now cosec of theta minus 45 degrees. So if we think about what's happened to this particular graph, and now I'm going to draw this. We've got now the graph, and when we draw, and I'll just draw this out, what I'm going to do is just start off with root 2 sine theta. So if we have now root 2 sine theta, we'll have something that looks like this. Okay, so we end up with it. So this point is going to be root 2. This is going to be now minus root 2. We've seen in a previous video that we can sketch now the cosec curve on top of that. So if we have that, what we'd have is something that looks like this, and then we'll come up, we'd have the asymptotes here, and then we'd have another one, and then we'd have something like that. So roughly that's what it's going to look like. So let's just go ahead and do that. Obviously that's just a sketch, but it'll give you some idea. Now what we're being asked to do is find the maximum and minimum values of this particular function. This was a maximum for sine, it's now a minimum for cosec. This was a minimum for sine, it's now a maximum for cosine. So what we've got then is simply a horizontal translation, let's move that there, of 45 degrees, and we'll just move that on. As inaccurate as that seems. Let's go ahead and locate this point just here. This now has moved, and we've moved from the minimum point. The minimum point was at pi by 2. So what we've done pi by 2. In fact, we're working, let's just switch this back up into degrees. So what we've got now, let's do that. We've got now this minimum point. So the minimum point has moved from 90. So we've come across, so plus the 45. And then we've got that value of root 2. And this is a minimum. So we can see that that's going to be 135, comma, root 2. Now let's look at this point here. It was here, and that is 270. That was the minimum of sine, the maximum of cosec, and that was minus root 2. So we've moved it on, so we're going to add the 45. So it's going to be 315, and then we're going to have now minus root 2. And this is a max. So if we're looking at now at the first positive maximum and minimum values of this particular function, we can see that this now is an entirely different question. So do check what the question is asking you, and you can see by a quick sketch and using these trig identities, we can simply sketch and see that this now is a minimum and this is a maximum, whereas at this point sine is a maximum and sine is a minimum here. In a later video, we're going to look at some more exam style questions. So we'll look at a range of different problems. What I want to do is just finish with, I'd say, a practical example of this. So what I'm going to do is just do one more. And we're going to have now, and we'll just sketch something up. So we might have something that looks like so. So let's do that. And let's now put a right angle on. And let's say we've got something like that. So we've got now a picture such as this. Okay, and let's just sketch this up. Let's now put some dimensions on this, and we'll say now that this is going to be, this will be a right angle. Let's make that a right angle. Let's make that a right angle. Let's say that this is going to be 2 units. Let's say we're working in centimetres if you like. Let's double that up. Let's do that as 4. This is going to be a right angle. And let's say that this total length now is going to be 3.6. So we're coming from here to here. So if we label this up, we're going to have A, we'll have now B. Let's take this point, let's say that this is going to be C. Let's take this point to be D. So this one will be E, and then we'll have now C back down here. What we might want to do is find the angle BAC. So say we wanted to find this particular angle. So what I'm going to do is just put this up. So let's say we were asked, to find, and we'll write this angle, and then we'll have BAC. So let's see what we can do with this. So all we're given on this particular picture now are these two lengths. So this is going to be 2, this is going to be 4. B to D is 3.6, so all of that is 3.6, A to C is 2, and then C to E is going to be 4. And what we want now is this angle, BAC. So let's put that on. Let's say that this is going to be theta. Now this is going to be now 90 minus theta, which means that 90 plus 90 minus theta, which means that this angle right here is also going to be theta. Now, one way that we could solve this problem is to look now at making this length of 3.6. So if we look now at this triangle right here, what we've got is 2 sine of theta will be equal to the opposite. So what I've got here is 2 sine of theta, okay? If I look at this one right here, I've got the hypotenuse, and I could say that 4 cos of theta would be equal to this length right here. So all I'm doing is using basic right angle trig. So what I've got then is a hypotenuse of this one, and I want to find now this length. So I've got the angle, which is theta, and I've got the hypotenuse. Therefore, I can find the opposite. If I look at this one, and this is one of the many ways that you can do this problem, I've got now the hypotenuse, and I want to find this length right here, and that length is CD. So we've got the hypotenuse, and I want the adjacent. So let's now write this out. So if we consider now that C to D, so C to D is going to be 4 cos of theta. Okay, C to D is 4 cos of theta. If we look now at B to C, or C to B, B to C, is going to now be 2 sine of theta. So 2 sine of theta. So we can now say that 4 cos of theta, and then plus 2 sine of theta is going to be equal to 3.6. So all I'm doing is using basic right angle trig, and you've now seen that this has thrown us into solving this particular equation. Now, of course, we could simplify this if we wanted. We could write this as 2 cos theta plus now sine theta is equal to 1.8. So if we now look, this is in the form a cos of theta plus b sine of theta is equal to a constant. So let's go ahead. Let's find the value of r. Well, r is going to now be the square root of 2 squared plus 1 squared. So r is going to be the square root of 5. So that's our value of r. We know that we can find alpha now by simply taking this. So what I'm going to do is just write this in the particular form. So I'm going to choose this now in the form, and we're going to have for this particular one, let's take r cos of theta minus alpha. Now, when I've got theta in this particular case, we could have 2 theta. It really doesn't matter. You could have 3 theta. We're just using theta to begin with. So let's look at this, and what we can do then is find the values of r. I've just gone ahead and said straight away that I know that the stretch is going to be root 5. So let's just expand this out. R cos theta cos alpha plus r sine theta sine alpha. So what can we say? Well, what we're looking then for is r cos alpha. R cos alpha is going to be, and we'll write this out, just equating the coefficients. R cos alpha is going to be 2. We can see that r sine alpha is going to be 1. So if we want now alpha, we can say now, and just writing this out, sine alpha over cos alpha is going to be equal to 1 over 2. So we can say from here that tan, so let's say that tan at alpha is going to be 1 over 2. So alpha is going to be equal to the inverse tan of 1/2. We'll work in degrees in this particular question. So let's go ahead and switch this up. So shift mode 3, let's put this in degrees and take now the inverse tan. Let's do the inverse tan of 0.5. So that's going to give me now 26.56. I'll say that's going to be 26.6. So let's say that's 26.6. So what we've got now is alpha is equal to 26.6 degrees. Now when we come on to, and I'll just put that there, that's 3 significant figures, so 3 SF. Okay, when we come on now to solve this, quite clearly we've got to have now that theta in this particular case is going to be an acute angle. When we solve this equation that I'm going to just set up now, we would obviously have subsequent solutions in a given interval, but because we know that theta must be an acute angle as within this right angle triangle, then we only need to consider it first. So what I can do now is write this as the root of 5. Remember, I've put it in this form right here. We've got the root of 5, and then we're going to have cos of theta minus the 26.6 degrees, which I'm going to store in my calculator. And that's going to be equal to the 1.8. So all we need to do is go ahead and solve for this. So just dividing both sides by root 5 and taking the inverse cos, we can say that theta minus the 26.6, which is stored in my calculator, will be equal to the inverse cosine of 1.8 over root 5. So all I've done is divided by root 5 and taken the inverse cosine. So let's go ahead and I'll just store this in. Shift store A. And then what we'll do is just take the inverse cos. So let's take the inverse cos now of 1.8 divided by root 5. So root 5. And then that's going to give me now, let's bring it out to the denominator. That will give me a value of 36.39. So what we can say then is, and we'll write it just here, theta minus 26.6, which is the answer in my calculator, is going to give us this principal value, which is the acute angle that we want, 36.39. So 36.39 dot 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 dot. So all I'm going to do now is add these two, 36.39 dot 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 plus now the calculator value I've got, which is 26.6, correct to 3 significant figures. So let's now add to this, and we'll add now the value of A. So that's going to give me 62.95. So we can say that theta is going to be 62. So what have we got? 62.95. Let's say I'm going to give that to 2 decimal places or 4 significant figures. If you want, you can just give it to 3 significant figures, 63.0, or you could say 62.96. In a question, you'll be asked to give it to a certain level of accuracy. So that now is to 2 dp or 4 SF. so 4SF, or we could say 63.0 degrees, and that would be 3SF. Okay, so let's look at that. Let's just do that. Let's just store that in. Shift, let's just store in as, what we've already used, A, so let's just store in as A. We can, no problem at all with that. Now, let's just go there. If we do now, we wanted this length right here, we can just confirm that that's correct. So if I wanted now this length here, so if I do now 2 lots, let's do 2 lots now of the sine of the answer that I've just put in here. Let's put that in, and then we have now plus, and all we're doing is using this, plus now 4 lots of the cosine, let's do that, of the answer. This should now give us the 3.6 that we want, and there we go. Okay, so you can check your answer by subbing back in. So that's a practical application. So there we go, that's Rcos of theta plus minus alpha and Rsin of theta plus minus alpha. We've been going some time, and I've kind of been doing that a bit off the top of my head, but hopefully that has given you enough information now to answer these particular types of questions. And often it's up to you on how you want to decide. So let's just look at this right here. I could have expressed this now. Let's just write this out as R sine of theta plus alpha. So when you expand this out, you can have R sine theta cos alpha plus R cos theta sine alpha, and you could have used that. Entirely up to you. I prefer working with the cos, with the negative, such that we're not dealing with these negative values all the time. So there we go. In the next videos, we will look at some typical exam style questions that involve this particular form.